You know that tiny, unexpected shock you get from a doorknob? Or that weird magic that makes a balloon stick to your hair? Well, that's static electricity. And today, we're going to find out exactly what's going on behind that little spark.
I mean, we've all been there, right? That sudden little jolt, or the fun of making a balloon just defy gravity. But what if I told you these aren't just random, weird quirks of daily life?
That's right, every single one of those zaps and every bit of that cling is actually the grand finale of an invisible, microscopic showdown. So, okay, let's dive into this and see this little atomic drama for ourselves.
So, how do we get to the bottom of this? Well, we need to go small, like really small. It's time to meet the tiny particles that are the real stars of this show.
Just think about it. Everything you can see and touch, the chair you're in, the air you're breathing, even you, is made of trillions and trillions of these tiny little building blocks called atoms. And inside each one is a whole universe of even smaller particles.
So deep in the heart of each atom, you've got your positive protons and your neutral neutrons, just kind of hanging out. But the key players for our story, oh yeah, those are the electrons, these tiny, negatively charged particles just zipping around the outside. They're the ones that are always getting into trouble. Now, in a perfect world, the number of positive protons and negative electrons are totally matched up. They cancel each other out, and the object is neutral. Everything is calm, everything is balanced. But what happens when we throw that perfect balance into total chaos?
This is where it gets really interesting. See, all it takes is a simple rub between two objects to spark a tiny, invisible war over those electrons.
So you've got two objects, right? Both perfectly neutral, just minding their own business. But then, when they rub together, that friction gives some of those outer electrons just enough energy to jump ship. It's like a tiny, invisible heist, and it changes absolutely everything.
And this right here is the crucial point. The object that loses electrons is now left with more positive charges than negative ones, so boom, it becomes positively charged. And the one that gained them, well, it's now negatively charged. This imbalance, this is the secret engine behind all static electricity.
Okay, so how do we know which way the electrons are going to jump? You might think it's totally random, but it's not. Not at all. In fact, there's a kind of scientific leaderboard that tells us exactly what's going to happen.
So yeah, how can we predict which material is going to be the giver and which one is going to be the taker? It's like a pop quiz in physics, but lucky for us, there's a cheat sheet.
It's called the triboelectric series, and it's basically just a ranking of materials from the most generous electron givers all the way at the top down to the greediest electron takers at the bottom. It's our predictive tool. It's how we know.
So let's just look at a simple version. Materials like your hair or animal fur, they're way up top. They are super happy to give away electrons. But materials like plastic or rubber, oh, they're way down at the bottom, and they absolutely love to snatch up any extra electrons they can find. And that brings us right back to our balloon. When you rub that plastic balloon on your hair, the chart tells us exactly what's up. Your hair willingly gives up its electrons, and the balloon just greedily takes them. That's what creates the static cling that makes the magic happen. See? It all makes sense now.
All right, there's one more crucial piece to this puzzle. It might feel like we're just creating this charge out of thin air, but there's a fundamental law of the universe that says, nope, that's simply impossible.
This is the big takeaway, folks. Charge isn't created, it's just moved around. It's kind of like having a fixed number of poker chips at a table. You can shuffle them between players all night long, but the total number of chips never ever changes. Every single electron lost by one object is gained by another. It's a perfect zero-sum game.
So let's just run through the whole story one more time really quick. A little bit of friction gives electrons the energy they need to make a jump. They leap from a donor material to an acceptor. This creates a positive charge on one and a negative charge on the other. And crucially, no new charge is ever made, it's only ever moved.
And here's the thing, nature hates an imbalance. That buildup of charge is just sitting there, waiting, desperately looking for a chance to get back to neutral. So when you reach for that metal doorknob, zap! That's the charge making a dramatic, super fast escape to find balance again. It's the grand finale of our whole invisible atomic drama. You know, it all starts with the simple movement of these unimaginably tiny particles. So if just a little bit of shuffling can create a spark strong enough for you to feel, just imagine what's possible when we learn to control the flow of trillions and trillions of them at once. From lighting up our cities to powering the very device you're watching this on right now, it all begins with the humble electron. Makes you wonder, what other secrets are these powerful little particles hiding?